guys, it's Ella from Turnabot, and today I'm so excited. We have our very first how to build a Turnabot tutorial. So Turnabots are 150 gram Sportsman combat robots. Sportsman bots are great because they're non-destructive, so you can battle for hours on end without having to constantly worry about rebuilding and buying new pieces all the time. So today we are building our bot Slipper, and in case you're wondering, it is not shaped like a shoe. It comes from a combination of my dad's first name, Scott, who designed this bot, and the word flipper, hence Slipper. So Slipper is great at throwing other bots around the arena and flipping itself back onto its wheels in an instant. You will be amazed at how fast this bot is. So Turnabots are great whether you're completely new to combat robotics or if you're already an experienced bot builder. So if you're completely new, then we walk you through every step of the way, such as how to solder and how to put together all the pieces. If you're already an experienced bot builder, then you will love all of our components, such as our servos and our Malenki nanos and our high power N10 and N20 motors. This is all of the pieces that you will need to make your completed Slipper bot. The chassis, the link, right arm, left arm, micro servo adapter, plow, top armor, left armor, right armor, wheels, tires. So here is a side-by-side comparison of the finished product to the pieces. So here is the long spacer compared to that one. Here's the short spacer. There's the short spacer. And then the rod is in there. You cannot see it, but it's in there. And then this is the paper clip. So here is the servo, and then here's the servo in the bot. This comes with the servo adapter. So there are two different options that we may send to you. Some people may get the small servo with the servo adapter, but then other people may get a larger servo and you don't need a servo adapter. Either are great. We just had two different orders. So the servo, and then here is the servo horn. There are several different horns included in the box that we send you. We use the single-bladed red horn, and then the horn's right there. It attaches to the servo. And then the switch is available from the bottom, and here's the switch. So in this kit are 10 screws. The smaller ones are 1.5 hex screws, and the larger ones are Phillip. So the hex ones are for the top armor and the plow. The Phillip screws are for the two side armor pieces. Now it is finally time to put together all of our components. This is the micro servo adapter being put onto the servo. There is a slot in the bottom of the adapter so that it fits on. It is a bit tricky to put on, but once it's in there, it's super secure and it won't come out. So we will speed through a couple of these steps to make it faster, but if you fall behind or get stuck, you can just either slow the video down or you can pause it. So I just handed the servo to my dad. He's going to screw it into the adapter, and now I'm going to put in the motors. I like to keep these pluses up so I know where the positive side is. It's always just a good practice to know where it is. It's more important with four-wheel drive bots, but it's always good. So then I'll put the other one in, also pluses up. This is to know where the wires are going to go. Time to put the battery in. It is intentionally a tight fit to keep it from moving around in battle. The wires go to the front right. Let's put the wheels and the tires. This is actually my favorite part to do very first when I get a Lego set. Next, we are going to install the servo into the chassis. You can see that the micro servo has been screwed securely into the micro servo adapter by my father, who is on the other side of the table. Time to connect the motor connectors. The red side goes to the plus, which is positive. If you have gone pluses up like we have, then it is on. You'll put the red wire to the front on the right side, and you'll put the red wire to the back on the left side. I am putting a little piece of blue tack down so I can put my motor connectors there without them moving around, so it's easier to see where to trim them. The kit comes with a small piece, so you don't have to worry about going and buying some if you don't already have it. The right side is more towards the front of the bot, and the left side is more towards the back. You want to make sure that the motor connectors are centered in the middle of the motors. Now we're going to use flush cutters to cut the wires flush to the cap. To cut the motor connector wires, you want to make sure that it is flush with the motor cap, not the terminal, because after we strip them, we want to be able to solder the wires to the side of the terminal, not the tip of it. Next, we are going to put in the Malenki. Fun fact, that was actually the 41st Malenki that I soldered. My dad is helping me show you how to route the wires to know where to trim it on the Malenki. It is also roughly equivalent to flush with the edge of the battery. Time to do the same thing with the left motor connector. It is about 2 millimeters out from the side of the battery instead of flush with it, because this one goes up instead of down on the Malenki. Next, we are putting in the switch. So this is actually your preference, the height that it sits. The lower it is, the easier it is for you to turn it on and off. But then it also makes it so your opponent can get to your switch and turn you off. We like to use blue tack to hold it, but it does mean that you have to open the flipper and push it down to be able to switch it on, but your opponent won't get you. You could also super glue it in place. It's completely up to you. Now we're installing the JST battery connector. The red wire will connect the positive lead of the battery to the middle leg of the switch. The black wire will connect the negative lead of the battery to the B- on the Malenki. We then use what we clipped off of the red wire to connect the far leg of the switch to the B+ on the Malenki. Cut the red wire to the far side of the B+ hole. We cut it to the far side because we're going to have to bend the stripped part of the wire into the hole that's going to go through the Malenki. Make sure that all of your leads actually go all the way around and touch the side of the chassis and they don't like curve short. We're going to cut the black wire the same way, except it's going to go all the way out to the far side of the B- hole. Now we are going to take all of the wires out of the bot and strip them about 1 to 2 millimeters from the end. You can use any kind of wire stripper that you want. Here we're using a more traditional version. After shooting this video, or this portion of the video, we decided to purchase a pair of auto strippers, and to make it a lot easier. If you're going to do a lot of wiring, then they're definitely worth it. Okay, it is time to flux our wires. We are using a flux pen. You can use either that or paste. Some people may think that it's a waste of time, but once you deal with wiring and tinning, you will know that it is well worth it. The flux is so the the solder, when you're tinning it, will wick into the wire and just get it really good, so it has a good joint to whatever you're soldering the wire to. You also want to make sure you flux the motor terminals and the switch terminals. Now it is finally time to tin all of the exposed wire ends and the terminals of the motors and the switch. So we use blue tack to hold all of our wires, to have them all accessible so we can just go through in one run to tin everything. For our motors and our switch, we also use a thing of blue tack to get a good and stable mount so we can do our tin pads. If you are new to soldering, we have a link below to a good soldering basics video. You can see that I have cleaned the tip of my iron and now I am wetting it with solder. The solder pillow helps with heat transfer to whatever you're soldering or tinning. You can see that to tin the wires, I put the iron behind the wire and I put the solder in front of it, and then I just touch the iron to the wire to get some heat into it, and then I feed the solder into the wire to just get it nice and covered with solder, and then you are done with that wire. Similar to tinning a wire, when you tin a terminal for a motor or a switch, you just get a good solder pillow on your iron, and then you stick it behind the terminal and you just feed the solder into the terminal. For the motors, we love getting like a lot on there, because one of the ways that you get killed most in battle for like damage is getting the motor wire unconnected from the motor, and because that shuts your wheels off. So after you have tinned all of your terminals and wires, it is finally time to start soldering your components together. So to solder a wire to a terminal, you put the terminal next to the wire and you just heat the joint so that they stick together. After they are stuck together a little bit, you feed some solder into it to get the joint more strong and so it doesn't like break off or anything. We are now placing the motors with the motor connectors into the bot. The left motor connector will end up closer to the back of the bot after we solder. We're just getting the wires routed to the Malenki and then secured to a mound of blue tack to solder. The wires from the left motor connector will go through the holes in the Malenki marked with the L. The black to the minus and the red to the plus, because the black is negative and it goes to the negative on the Malenki, and the red is positive, so it goes to the positive on the Malenki. With the stripped and tinned wire ends poking through the holes and secured with blue tack, we can solder the leads for the left motor. After cleaning your iron tip and wetting with solder, touch the iron to the ring of the through hole for a moment before letting the iron touch the wire. This helps the solder flow through the tinned wire to the ring. You may flow just a touch more solder, but remember you want a small volcano shape, not a bubble, and no exposed wires or ring. Now we'll secure the wires from the right motor to the R holes on the Malenki. We use blue tack to hold the wires fully through the rings and in the shape that we want them to stay in after soldering. Once again, we will be soldering the red wire from the right motor to the positive R hole and the black wire from the right motor to the negative R hole. Place the Malenki and motor assembly back in the bot with the left motor connector towards the rear of the bot. The Malenki tucks between the right motor and the battery with the top edge tipped toward the front of the bot. Route the cut red wire around the edge of the bot. One end will be secured into the B+ hole on the Malenki. Now route the black wire from the battery connector to the B- hole on the Malenki. Sometimes the tin bulb on the end of the wire might be a bit too thick to fit through the Malenki's hole, or it may be too long. Just clip the solder and then it'll easily fit through. After that, with the red and black wires fit snugly into the Malenki's holes, secure it all in place with some blue tack. You may need to get a better angle on the Malenki to get heat where it's needed. It can be very helpful to have someone hold it or prop it up and secure it on something. Soldering is all about controlling the heat. Solder is drawn to heat. So you want to touch the iron to the ring first on the Malenki to get a moment of heat into the ring. Then slide the iron to also contact the wire for another moment. And feed some solder into the joint. When done correctly, the joint looks like a little volcano. If you've put too much heat into the blue tack, you can use the mound of blue tack to get it off the wires. The next step is wiring the switch. You can see how the wires will route. Again, we'll use blue tack to hold the switch while we solder. As the switch is near the front of the bot, where it'll take more shock from hits in the front, we found the best technique is to get both the wires and the legs well tinned and get as much contact as possible between them. Work holding is often the biggest factor in good soldering. In this case, my dad is helping me with the work holding. Normally we might use helping hands or more blue tack. Once soldered, the switch just tucks into its slot. Then we'll wire up the servo. Always make sure that the wires line up. Signal, power, ground on both sides. Making sure that you have plenty of length, cut the connector off so that you can separate the wires. The signal wire will be separate from the power and ground for nearly 2 inches. The power and ground wires will only be separate for a few millimeters. Make sure that the ribbon lays flat on top of the motors. The power and ground wires for the servo will go to the power and ground wires from the battery and the switch that come through the Malenki Nano. This image shows you where the yellow signal wire will be soldered. With power and ground trimmed to length, we can lift the Malenki out, line up the power and ground, and cut the signal wire flush with the far side of the solder pad closest to the holes. Again, you only want to strip 1 to 2 millimeters of insulation from the ends, and you can use anything, but you shouldn't use your teeth. We just got these strippers on Amazon for $12, and they are well worth their money. We'll flux, tin, and solder the 3 servo wires to the Malenki. The power and ground will be tacked to the wires from the switch and battery. The signal wire takes just a moment's heat to join well with the pad. This is the entire slipper harness. If you bought a pre-soldered kit, this is what you'll receive. This is the first time we can use the Malenki to control the servo, which is why we didn't put the screws in from the servo adapter to the chassis. Connect to the servo, make sure it's ground to ground and signal to signal. With these wires, that's brown to brown and yellow to yellow. At this point, we'll go ahead and bind the radio and set the servo position. Turn the switch off, connect the battery. If you're adding this slipper to a radio that's already bound to other bots, hold OK to get into setup, click OK to enter system setup, click OK again to enter model select, click the up button to go to the next model number, then hold the cancel button to lock it. Click the cancel twice more to get back to the main screen where you'll see the new model listed in the middle. Turn off the controller. You're using the same step as setting up a new radio. If you're setting up a new radio or have selected the new model, turn on the bot switch first. You should see the blue lights flashing on the Malenki. Hold the bind key down while turning on the radio. When you see the RX bind OK, the radio is now bound to the Malenki. The blue LED will go from flashing to nearly always on. Moving the drive stick will put the Malenki back into operation mode, and you can now see the drive motors turn and actuate the servo. If you haven't set the horn position on the servo yet, now is a good time to do that. Once you're sure that everything works as it should, you can start to put it all together. This is also where you'll start with a pre-soldered kit. Having installed the servo horn in position, we'll now fully install it. A long, thin Phillips screwdriver is quite nice to help install these. If you prefer to install hex drive, you can use any M2 screws. It's easier to do this before installing the motors. As these screws mount to the powerful servo, you'll want these good and tight, but remember it's just plastic, so take care not to strip it. If you'll be swapping batteries a lot and or charging them outside the bot, then you don't need to put the battery charging connector into the mount. With everything so compact, the battery charging connector is necessarily hard to get into the mount, but if you're primarily going to be charging the battery in the bot, it's very nice to have it well mounted. It does need to go in perfectly straight to fit. Once the charging connector is in, you can tuck the battery with the wires into the front right corner of the bot. The red JST battery connector goes between the charging mount and the battery. You want the battery itself as protected from frontal impacts as possible. Slot the motors in. The wires tend to run best with the left motor connector furthest to the back of the bot. The Malenki tucks in behind the battery, and then you can route the servo wires cleanly across the bot to the servo corner. It's not a bad idea to check the functions again at this point. With everything working properly, you can zip tie the motors in. Make sure the motors are tight in the corners. You can use pliers to get them very tight, then use flush cutters to clip the tails. The wheels that we send out now are much easier to install than the early wheels. Regardless, make sure you line up the D-flat on the motors with the flat in the wheels. You want to superglue the tires to the wheels and the wheels to the motors for any serious battles. Next, we'll assemble the flipper. We provide a 3mm hollow aluminum rod in the kit, which makes a very solid lightweight axle for the flipper arm. It's easiest to assemble the spacers and the servo link, then press the arms onto each end. The arms are intentionally tight, but the link should move easily on the rod. If it doesn't, you can run a 1/8 inch drill bit slowly through it. Once the rod, spacers, and arms are together, we'll add the top armor. We use 2 of the M2 screws here. Finally, we'll add the plow to the flipper assembly with the 4 M2 screws. Straighten out the provided paper clip. You'll want to cut it just a bit shorter than the width of the back of the chassis. Then put a V-bend on one end of it. This will hold it in place. Pull one wheel off to slide the paper clip in. It's easiest and safest to use pliers to grab near the chassis to push the paper clip in a small amount at a time. With the flipper assembly installed, we'll use the Phillips screws to mount the armor and the last M2 screw to connect the link to the servo horn. Reinstall the wheels and you're ready to battle. Well, let's do the final radio setup before battling. Most radios require the throttle to be down to turn on the radio. In our case, that means the flipper down. You can have the stick down, turn it on, then raise the stick, which will keep the flipper up when you turn the bot on. If you turn the bot on with the stick down, the flipper will snap down and bite your finger. You also don't want it jammed too high. It's usually pretty safe to have the stick in the middle and turn the bot on. Slowly lower the left stick. If the flipper is all the way closed before the stick is all the way down, you want to lower the bottom endpoint. With the stick just barely holding it closed, adjust the bottom endpoint. To adjust the endpoints, hold OK, down arrow to setup, hit OK, down arrow to endpoints, OK twice to go down to channel 3, hold down the arrow until the flipper is not jammed into the bottom, lower the stick until it's just making the servo whine, repeat reducing the number and lowering the stick until the chassis barely lifts with the stick all the way down. With good servos, you can stall the servo very gently without hurting it. Slowly raise the stick. If the link hits the paperclip before the stick is all the way up, you want to adjust the upper endpoint. Once the stick passes halfway, the arrow will automatically move to adjust the upper endpoint. Hold down the arrow until the servo stops whining. Raise the stick slowly and repeat until the link barely touches the paperclip with the stick all the way up. Remember to hold the cancel button to save the settings. Check that the bot goes in the direction you want. If forward, backwards, left, and right are reversed, you can change those with reversing in the radio. If pushing forwards makes you turn, you may want to invert one side in the Malenki. In order to do that, you need a switch set up on channel 5 so you can send high-low pulses. You want to make sure that the switch is set so that the channel 5 is low with the switch up so that as soon as you turn on the radio, it is low. We often set switch D to channel 5, which is done in the aux channel settings in the radio. With switch D on channel 5, go to display to make sure that channel 5 is low with the switch up. Also check that channel 5 flips high when you flip switch D. Turn off the radio, then turn off the bot. Turn on the bot and wait 10 seconds to let the Malenki go into configuration mode. You'll see the blue LED flickering. When you turn on the radio, don't touch the sticks. To invert the left channel, flip the switch D, down, up, down, up. You should see the blue LEDs blink twice. Moving the drive stick now will put the Malenki back into drive mode.
Now that you've seen how easy it is to build, you can do it too! Thank you so much for joining us on our Turnabot adventure. You can find us on our website at turnabot.com and on Facebook and Instagram. If you have liked this video, then click the like button and subscribe.